Daniel, forever chemicals have become a major focus in the engineering industry. Can you explain what they are and why the engineering industry is so heavily focused on it currently?
Yeah. So PFAS are perfluoroalkyl substances, and so this is a wide range of chemicals. There are tens of thousands of PFAS that are out there, but the thing that they all have in common is that these are fluorinated organic chemicals. So these are carbons that are bonded with fluorine, so usually long chains of carbon that have very similar to like hydrocarbons, but instead of hydrogen, it's fluorine that it's bonded with.
PFAS chemicals have been manufactured since the 1940s and are widely used for their non-stick and water-resistant properties. They can be found in everyday items like microwave popcorn bags, food wrappers, film-forming foams, and waterproof clothing. However, these chemicals do not break down in the environment and can accumulate in living organisms over time. While research is still ongoing, exposure to PFAS has been linked to weakened immune systems and various health concerns, including cancer. As awareness grows, so does the need for stronger regulations and effective treatment solutions. In today's episode, I'll be talking with Patrick Haney, PE, MBA, Water and Civil Technical Lead, and Daniel Stockard, PE, Water and Wastewater Process Engineer, both experts in water and wastewater engineering from Stanley Consultants. We'll discuss the latest PFAS regulations, emerging treatment technologies, and the financial and technical challenges of PFAS removals. I'm your host, James Taylor, and this is the Civil Engineering Podcast, the industry's leading show for civil engineering professionals, ranked as the #1 civil engineering podcast by FeedSpot. It's now time for our civil engineering conversation of the week with Patrick Haney, PE, MBA, and Daniel Stockard, PE. Patrick and Daniel, welcome to the Civil Engineering Podcast.
Thanks, James.
Yeah, thanks for having us.
So I'm going to ask both you guys this question first. Can you each share a little bit about yourself, your career journey, and how you became involved in water and wastewater engineering?
I guess I'll go first. So my dad was a utility director for the city of Mesa, Arizona. His background was water, wastewater. I think he kind of guided me towards the industry. I had a couple different directions going into college, and I grew up on the water. I was a swimmer, water polo player in college. So the idea of just being in water was kind of naturally, a thing for me. So I ended up in water, and I'm glad I did. I've had the opportunity to work throughout the United States and really across the world on projects. And I've really come to love the process side of it, the treatment side, both at water and wastewater. So it's been a fun journey, 25 years in, and probably another 25 years going. Dan?
Yeah, so I'm originally from the Detroit area. My dad was an automotive engineer. So we always work on, home improvement projects, like the Pinewood Derby, all that fun stuff. I grew up a Lions fan, and so, had to, from a young age, had to evolve, problem solving skills. As well as being a Lions fan.
Being a Lions fan, I'm sure that was a little painful.
Yeah. It's finally paying off a little
There you
bit,
go.
but we'll see how long it lasts. But growing up, I was really interested, in like biology and science, sort of overlapping with, I was very interested in history and community planning, architecture, public works, that type of thing. And so I sort of tried to blend those two things into a career in environmental engineering, which is sort of at the intersection of all of that. So I graduated from Michigan Tech in 2017, then started a career off in environmental remediation, doing things, like a wide range of things, but looking at like PFAS delineations, responding to chemical spills, emergency treatment systems, trying to keep PFAS from spreading in the ground, and then also like implementing and operating systems that would like pump and treat it. Then went to grad school in 2020 at Northwestern, really trying to hone in on the water and wastewater treatment side of things. And that's when, after that is when I started my career at Stanley.
So you talked a little bit about PFAS chemicals and what you're doing there. And Daniel, forever chemicals have become a major focus in the engineering industry. Can you explain what they are and why the engineering industry is so heavily focused on it currently?
Yeah. So PFAS are perfluoroalkyl substances, and so this is a wide range of chemicals, or tens of thousands of PFAS that are out there. But the thing that they all have in common is that these are fluorinated organic chemicals. So these are carbons that are bonded with fluorine. So usually long chains of carbon that have very similar to like hydrocarbons, but instead of hydrogen, it's fluorine that it's bonded with. So this is the strongest bond in organic chemistry. And so it's a very resilient chemical. And so they can
Yeah.
stand up to like high temperatures. They're hydrophobic, so they're waterproof, very resistant to abrasion. And these are characteristics, that at the time, revolutionary products, really. So like Teflon nonstick pans, like rain
Yeah.
gear, firefighting foam. So if you want to
Yeah.
put out a fire, they're very good for that.
All the
Um,
great things that came out of that time period, right? Like, I mean, you're talking about all this great stuff that people really enjoyed using, and come to find out, it's actually been bad for everyone.
right, and it's a complicated picture there, but the the cause for concern is that the things that make them so resistant and good for our everyday use also makes it such that they don't degrade in the environment. And so that's why we call them forever chemicals. There aren't, it's a complicated picture, but most PFAS, uh, if they do degrade, they degrade into other forms of PFAS. And then there are these things called terminal PFAS that they wind up as, and those will never disappear in the environment. At this point, there aren't bacteria that are evolved to actually break those chemicals down. And so, they biomagnify, which means that as you go up the food chain, they tend to stick around and assimilate themselves from one organism into the next. And then within organisms, they bioaccumulate. So when you get it into your body, it takes a very long time for you to excrete it. So it tends to build up in like your blood and in your tissue. And so there's concern that long-term exposure to these chemicals can lead to health effects. And that's kind of outside of my realm of expertise, but
Right.
that's the broad idea.
So, Patrick, what type of owners or industries are going to be most affected by PFAS regulations?
So certainly most affected is an interesting term. Is right now we're really focusing on water and water treatment and keeping it out of our water systems, but every single industry will be affected by
Yeah.
this. So, certainly we're focused right now on getting out of drinking water. As Dan has noted, it does not break down, it bioaccumulates and biomagnifies. So, what we're trying to do is getting out of drinking water. And that's kind of the first step here. But as, Dan mentioned, this stuff's in, your water repellent gear if you like to go hiking. So, to the tribute of a lot of different, leading manufacturing companies out there and that focus on your winter gear, like Columbia, for example, that they are actively trying to find other waterproofing chemicals. So
Yeah.
it has nothing to do with drinking water or health or whatnot, but yet it touches that industry.
Yeah.
Moving forward, it's going to touch the food and beverage industry. It's going to touch wastewater. It's already touching landfills and leachate that's coming out of landfills. So it will impact the entire world in every industry just about that we operate in. Anything from metals manufacturing to the day-to-day interactions we have, all the way through industries that you don't even think about. So
Hmm.
right now, one of the methods for treating is using activated carbon or granular activated carbon or ion exchange. Well, you put these things in pressure vessels. Well, there's a lot of different industries that use these same type of pressure vessels and these same sort of chemicals and other sort of systems that you would use for treating PFAS. So they'll be impacted by it. So it's really a universal problem that's not going to go away anytime during our generation. It's going to be a long-standing challenge that we're going to need to take care of over time.
Yeah, I think I saw a diagram recently where it kind of showed uh, the life cycle of PFAS, well, or how things are going. Where you might have good water at that point in time, and then it gets used in a process, and then the water is now contaminated. It goes into our wastewater system, which then goes into our water system, which then, and it's like, oh my goodness, like no matter where you touch, it's there. and
Right.
it's a major issue that we have to solve.
Yeah,
Um,
and just to play off of that, when you say you compare PFAS to like PCBs are another class of chemical that was emerging contaminant a couple decades ago. If you look at like the ultimate fate of like the PCBs, which are chlorinated carbons, they tend to they tend to stick to sediments. They tend to end up in soils, and over time, that will, the more sediment will deposit onto it, and it enters into the geological cycle where there's
yeah,
not as much risk of exposure to human populations. Not to say that there isn't that, but there's emerging evidence that in PFAS, the ultimate reservoir where it winds up is in living things.
mm. So Patrick, you mentioned a little bit about the carbon or the activated carbon. I'm going to ask this question to Daniel: is PFAS treatment solutions one size fits all? Because all I've heard really is about the carbon aspect. But are there things that they depend on the site specific circumstances?
Yeah. So it definitely will vary by site. And so I think when you're looking at the environmental engineer's toolbox, GAC is a very versatile, and it's sort of your go-to tool when you want to deal with a compound that can absorb to GAC. And GAC in and of itself is a whole can of worms. There are many different types of GAC. Um, and there are ones that are better for treating PFAS. You can target the type of GAC to the type of contaminant that you're trying to treat. But broadly speaking, no, the specific site and the water quality on that site is going to have a huge impact on what will be the most cost effective treatment for the PFAS that you're trying to treat. So give an example, one of the projects I was looking at, we did some bench testing, and the PFAS just chewed right through the GAC. Whereas like the ion exchange resin, we expect that we get many, like 18 months before you'd see PFAS breaking through. And so in that time, you'd have to do, like 5 or 6 GAC change outs to get the bang for your buck for like one ion exchange change out. And that can be due to a lot of things, like co-contaminants. If you're dealing with like a surface water, you might expect higher loading from other organic compounds that can compete for sites on your carbon. And so maybe an ion exchange resin that's more targeted for that PFAS. It's not going to be it's not going to care as much about the other organics that are in the stream. But on the other hand, if you have like high chlorides or high nutrients like nitrates, so PFAS are negatively charged, and if you have other negatively charged anions in your water, those can compete for sites on your ion exchange resins. And so that initial influent characterization, that wide-ranging testing is really important to try to suss out like what the best solution is going to be for your particular site. Is it surface water or is it groundwater? If it's
Yeah.
groundwater, does it have like iron and manganese in it? These are questions that you want to ask.
Yeah, and just to play off of Dan there, there's more than just, these media solutions that are out there. We're removing PFAS with membranes. There's a technology called foam fractionation where we're basically using charged bubbles to float solids out of liquid columns. And so that ultimately, then you have to deal with that concentrate. And that's where right now, a lot of the different media solutions are still part of that process. There are a lot of different processes that are under, I will just say development for actually destroying that bond, that carbon fluoro bond. And usually they're pretty high energy, high pressure. Seems to be the general approach right now, whether that's incineration, supercritical water, alkalinity treatments, along with that high pressure, high heat sort of situations. Certainly some technologies that are under development using photolysis or UV. So there's a lot out there. It's not just
Yeah.
GAC and ion exchange. It just happens to be that those two approaches, along with some other novel sorbents, are the technologies right now that are more mature and they're being used a little bit more readily. I think we'll see in this space that just within the course of the next 10 years, a lot more development, a lot more options when it
Yeah.
comes to treatment as these new technologies that are out there are developed. There's a lot of money is going into technology development in this field, and I think that we'll end up in a better place in, like I said, 5 to 10 years from now, after some of these technologies are fully developed and then brought into a scales of the economy.
So Patrick, what are with when it comes to PFAS regulations, obviously some of this is very new in kind of being enforced down. EPA has the requirements. Some of the states are still trying to figure out how they're going to be enforcing the PFAS regulations. What are some of the latest developments in PFAS regulations, and how might they impact civil engineers and the industries affected by these changes?
And that's a great question right now. So, at a federal level, last year we received drinking water regulations limiting our PFAS and PFOA to 4 parts per trillion, along with a hazard index for a slew of other compounds. Not going to explain that right now, but what we're seeing was an April of 2029 implementation date that states needed to comply by, or all drinking water providers would need to provide by. We haven't seen that touched since then, but we have seen a lot of different states and different entities out there trying to challenge the science behind that limit. So, what I would see if I had a crystal ball, which I don't, nor would I bet on my statement, but I would potentially foresee a relaxation of that date to try to allow for different utilities to be able to implement that plan. It takes a while to actually do this correctly.
Right.
As Dan would note and would very well get into the details of how long it takes to actually go through bench scale testing and jar testing and make sure you get the right solution with a heavy review of things such as O&M costs and residuals management and everything else that goes along with these systems. And that's just the planning up front, plus the actual designing and construction. It's really about a 5-year process if you're going to do it right. Now, certainly you can slap something together with a design build over the course of 6 months to a year, but now you're stuck with usually higher operations costs associated with that. So I think that from a regulatory standpoint, we're not going to see a lot of changes in the next 4 years, maybe a delay. Longer term, bigger picture, we've certainly seen at a state level, different states trying to approach surface water standards. So not
Yeah.
just drinking water, but what can be discharged to the surface water. That will not be fully implemented, under the current, federal administration in terms of wastewater or discharges from industrial facilities or what have you. So I think that we are, in a position right now where we're not going to be looking at new regulations over the next, 3.5 years, but come a different administration, different EPA, that could change.
Do you see them change? You mentioned relaxation of the time frame for implementation. Do you see anything changing with the parts, the level that it has to meet, not just the
That's
time
a little
frame?
bit of a tougher
I
sell,
can
I think, from a federal standpoint, where you've got a lot of people that have become aware of this issue,
Yeah.
and they're lobbying their congressmen and women about trying to make sure that they got the money there to be able to tackle these issues. I don't see the federal government relaxing that standard.
Oh,
I don't
Patrick, can
think the
I
political.
hop in?
Go ahead. Oh, Dan, you've got some thoughts.
Sorry,
This
I
is
read a
this is
I read a
this is
policy bull.
interesting because everybody's going to have a different opinion on this topic. Dan, go
Right.
Sorry,
ahead.
Exactly.
I read a policy bulletin on this a couple of days ago. So Lee Zeldin, the administrator of the EPA, and Shelley Moore Capito gave a presentation that addressed PFAS very briefly, but they said that they were taking a second look at the MCLs and whether water utilities, could reasonably be held to, treating this down to basically non-detect levels. So it's something that they're looking at. There is a rulemaking procedure to change MCLs that would take several years. But I think Patrick's right, though, that in some ways, this there's public awareness of this. It's in drinking water, and regardless of what the ultimate MCL is, I agree. I'd be very surprised if it's removed entirely.
Yep, I concur, Dan. I don't think it's going to get. I don't think it's going to change. They'll go through the process, but by the time they go through that lengthy process, it'll probably be looking at potentially a new administration,
Yeah.
and that'll change things. What I do see, though, is more in the distant future regulations on biosolids, wastewater treatment plant discharges, and other discharges. And that's something that states are already requiring, a lot of wastewater treatment plants to start monitoring.
Yeah.
Certainly, Maine, I believe, has limited wastewater with PFAS in it cannot have biosolids land applied, and that's a big change for our industry. So there could be wider sweeping changes at a wastewater level beyond the drinking water level as to how we manage wastewater with regards to PFAS.
Right. And how we should manage it too.
Right.
Before the promulgation of the Clean Water Act, there were wastewater plants. There were municipalities that were, saw the functional value of water treatment. That's been around for decades before there were
Yeah.
even federal regulations for both drinking water and discharging, the NIPD system. So, just pragmatically speaking, I think that in the industry there'll be discussions of how we should handle those residuals from a disciplinary standpoint.
Right. Daniel, you recently conducted some sampling for a federal client. What are some of the key results of the testing, and what insights did they provide about PFAS contamination?
Sure, sure. So we are doing some influent characterization for treatment of PFAS impacted surface water, um, and we really wanted to get a grasp of what are the operating ranges of the PFAS and water quality parameters that we might expect to run into if we're running the system 24/7. We've taken grab samples here and there that give us a good idea of like the averages, but what are the extremes that we're going to have to contend with, that the system will have to contend with? And we'd seen visual observations that when it rained, like the water quality just visually gets all murky, giant storm flows. And so we want to know what is that water like. And so we did some single rain event wet weather sampling, which can be logistically challenging. You have to have somebody ready to go out and do it whenever there's a rain event. But we wanted to track the progression of water quality over the progression of a storm event. And what it showed us was that the organic content skyrocketed, the solids content skyrocketed. We saw some flashes of like metals that were close to non-detect in other situations, things that if we were to try to pump that into our system, we would have some serious problems in like basically gunking up our treatment media. And so that led us to ask how do we actually fix it? How do we treat this water before it gets to our media? What extra steps do we need to add? And we start laying out a process flow for how to address these things. And we ended up doing some additional jar testing on that dirty water. And what we found is that we're able to cut down a lot of it, if we pick the right coagulants and flocculants. So these enhance like gravity settling of particles in water. When we pick the right ones, we were able to knock down our solids significantly. We were able to knock down the metals, so we're not as worried about those following up our media. And we were also able to reduce like the organics by about half, which wasn't quite where we needed to be, and so we needed to add another treatment step in between basically the gravity filter and the PFAS adsorption vessel. So we added another media that was targeting removing that non-PFAS organic matter, so that we don't get bugs growing in the adsorption vessels for the ion exchange resin. And so that sampling was really key to us crafting a solution that'll actually work and not run straight into a tripwire that's waiting whenever it rains.
Patrick, what analytical tests should municipalities and water treatment facilities perform to assess PFAS levels in their systems?
So the EPA method 537.1 version 2, say that 5 times fast. That is the method that is currently recognized as one of the preferred approaches for actually going out and doing that testing, that's going to test a suite of different PFAS compounds. And I like to think about this kind of like how you think about like an oil or a gas, where you have different numbering associations with the number of different connections there are. So like a PFO or PFOS, that's that O is that octa, which means there's 8 connections, and this will do it everywhere from the 2 to 3 different PFAS actual links all the way up to something much more higher and complex. So that's going to get your standardized suite of PFAS and PFOA sort of compounds, and I'm not going to name them all off here. But I think the better question is often, what other tests do you need to take, and
Yeah.
where do you need to take it, and how frequently do you need to take it? So I've come across this, and it doesn't matter if it's PFAS, sort of PFOA sort of challenges, or any other compound, and that's having the right data available to be able to make informed decisions. So if you know that you have a groundwater source, which is probably the most common right now, and you want to treat this thing, you're going to go through and do your EPA 537.1 version 2 testing of all the different potential PFAS compounds, but you also want to test for other compounds. So, we talked a little bit earlier about pre-treatment. We know that if we're going to use an iron and, an ion exchange system, we know that iron and manganese is something that's going to follow that resin.
Yeah.
So we need to test for a whole suite of different compounds that are out there to be able to make the right informed decisions on what's the most cost effective and then also, process-wise effective removal for the PFAS. So, and then there's that duration. If usually if we're talking groundwater, we're not expecting major changes over a short term. Certainly, PFAS plumes can move, concentrations can change, but if you're looking at surface water, as Dan mentioned, you're going to have a lot of changes that happen in that water over time based off of whether it's a rainfall event or if it's dry out. So you really want to capture all the different sort of situations that your facility could be operating in. The same thing on the wastewater side. They'll use a similar EPA method on the effluent side. I'm not familiar, Dan, maybe Dan is, on the testing that we'd be using on the influent side of a wastewater plants. Certainly, there's been testing throughout the plants. And one of the interesting thing when you think about testing within a wastewater plant is that we've seen within aeration basins, PFAS go up. So that oxygenation, that oxidation of precursor compounds can actually increase
Right.
the PFAS being discharged from a wastewater plant. And everybody's scratching their head and say, well, this wastewater plant is actually creating PFAS. Like, no, it's not. It's just taking what's coming in, and it may be, sometimes we call them Gen X compounds, but these other sort of precursor compounds that then can become a perfluorinated compound that we measure. So, I mean, I kind of going down a rabbit's hole here, but
Yeah.
really the idea
Yeah.
is not just PFAS. It's, the whole suite of different, water quality parameters that are out there that you need to test for, especially in drinking water and wastewater, so that, you've got the full picture and what's the best approach to be able to, get in within compliance and also do it in a cost-effective manner.
Yeah, and Patrick, that point about PFAS seemingly growing within wastewater. One way that and it's not super refined, but a quick and dirty test that you can order up is called total organic fluorine. And if you have a lot of organic fluorine in your water, but not a lot of like terminal PFAS, it might give you an indication of if you might expect to see oxidation of those longer chain PFAS into those terminal PFAS that we're concerned with most.
So let me ask you a quick question. So my understanding is there's a ton of forever chemicals out there, these PFAS, but there's only a limited number of them that are able to be detected currently with certain tests. And is that correct? I mean, is there things still that are unknown out there that are still considered forever chemicals that like you might be testing now and it might not show up, but you're going to test again in a couple of years and with a different test and more might pop up? Is that what we're saying?
I think you're accurate there. So, depending on who you're talking to, and this number keeps changing, gosh, just a couple of years ago, we were saying there was about over 5,000 different perfluorinated compounds. And then I've heard numbers up to 20,000.
Right.
Chemists do some amazing things, and they have certainly, latched on to that, carbon fluoral bond, as Dad mentioned, being the strongest bond known, to man, at least organic bond. And they've done a lot of things with it. But right now, we're only focused on these compounds that are the most common. So, just because we've got 5,000, 20,000 different compounds out there, they're not readily used in the environments, and they have not become common enough for us to need to regulate those compounds. The other aspect of it is a lot of those compounds will be removed by the same mechanisms that we're
Yeah.
already talking about. But because they are not as common as, say, PFAS, PFOA, the most common of the PFAS compounds or perfluorinated compounds, that they're not going to be detectable to the same levels as these other compounds that are out there. So, but it would not surprise me if, as we solve this issue, that additional issues come
Yeah.
up. That's just kind of the nature of the industrial revolution and chemistry, and our understanding of the impacts of what we've done to the environment. And that's why you have a great field of environmental and civil engineers and scientists that are out there that are finding the solutions to these challenges.
Yeah,
Daniel, when it
and
comes to treatment, what are the key differences between capture and destruction technologies for PFAS treatment? And how do site conditions influence the method which is most effective?
right. So, there are kind of two things here. First, like the destruction technologies are usually taking a concentrated PFAS stream that has been produced from a capture technology. So this is usually, if you want to destroy the PFAS, there's usually an initial concentration step that will involve um, like either GAC or ion exchange, or like foam fractionation in particular is very good for as a pre-step to destruction. And so those capture technologies are looking at removing the PFAS from the bulk liquid into some compartmentalized form. So either at the surface of the air water interface, or onto some sorbent, and then you're taking the sorbent or the foam that bubbles up off of like a foam fractionation vessel. You're setting that into a destruction process, because if you try to heat up, like say that you're trying to use a hydrothermal alkaline treatment to destroy PFAS, do you want to heat up millions of gallons of water per day, or do you want to try to do thousands of gallons
Yeah.
of water? It's a lot more economical to destroy it when it's a smaller volume. So it's sort of a multivariate question of what's the best capture technology, and then what's the best destruction technology for that capture technology. And so there are things like, if you're looking at foam fractionation, sometimes you add another surfactant into that to help to enhance the capture of PFAS, or get a broader spectrum of PFAS that you're capturing. Because like we are talking about, there are tens of thousands of these chemicals, and not all of them sorb as easily as others, or separate as easy as others. So you might
Yeah.
add something to like a ammonium surfactant, for instance, but then that could affect like the downstream destruction process. Maybe it's not a good idea to put the extra chemical into the giant, basically pressure cooker. You kind of pressure cook the PFAS to oxidize it in some cases. And so this is where it's really important to, if you're thinking about this, you should be talking with vendors who are developing that capture technology, and what they might do in the intermediate before it gets to the destruction technology, and talk with that destruction technology vendor. Okay, what are some red flags that you want to watch out for? What are some things that could affect this process, negatively? And so you have to think of every step in the process and how they affect each other. And the ultimate solution might not be the one that you thought it was going to be when you first started putting pen to paper. There's going to be something, if you ask the right questions, there's going to be something that comes up that makes it less of a crystal clear picture. But you got to get ahead of that before the operator finds out, and then comes calling about why why something blew up when it wasn't supposed to.
I'll add on to that, Dan. And right now, I think capture is going to be happening at that local level. So wherever you've got the PFAS, you're going to be trying to capture it. Right now, we're still in the technology development side of the destruction part of it.
Yeah.
And there's been some discussion about regional destruction centers. So you may capture this concentrated PFAS liquid, and maybe it's at a city, a metropolitan level. Maybe it's at a county or regional level of some way. Maybe you're shipping, this resin or concentrated liquids or what have you to a destruction location. And again, this is kind of where we talk about technology development a little bit differently, and that, that could start off as a regional sort of center. And maybe as technology develops and things become more cost effective, you do it more at a site level or, multiple locations throughout a city to a single
Right.
site level. So I think that, again, it's going to be a while before we get to that point where, you're able to just destroy it on site.
Yeah.
That could take decades, but I think, as we're seeing, technologies roll out, that's kind of the approach that we're going is capture it locally, destroy it regionally at some sort of regional destruction facility. And on the wastewater side, on the biosolid side, we're already hearing people talk about regional incineration sites or other sort of methodologies to manage biosolids that would be more cost effective than just doing it at each individual wastewater plants.
Patrick,
Yeah.
I'm sure some municipalities are sitting there thinking, great, another unfunded mandate, something that I have to do. Obviously, this is good for the public health, safety, and welfare, so it's important to do. But I'm sure they're seeing dollar signs. And with PFAS removal being costly, what financial or funding options are available to help owners comply with regulations?
Yeah, so a lot of those are being rolled out at the state level right now. We're not seeing federal funding that's dedicated to this issue just yet. So I'll give an example. In Minnesota, there was a settlement with a manufacturer of PFAS that money is going towards treatment for those impacted by their plume, as well as environmental improvements and whatnot. But you have to be kind of hyper local to that particular settlement to get that money. So what we're seeing is a desire for that money to occur, and it doesn't matter which side of the aisle you're on. They want the polluters to be the payers.
Yeah.
They want, if you created this thing, whether it was an, AFF, aqueous firefighting foam solution that impacted a airport in the middle of Timbuktu, or if it's, directly being impacted by a plume that's associated with the manufacturer, you're seeing both sides of our political aisles pointing towards those polluters to pay for it. Unfortunately, money's not there yet.
Right.
Not we've got like you said, an unfunded mandate. You need to get there. We don't know how to pay for it. I think that's another thing that could drive the implementation date back a little bit. I think the question is how. So some folks, some of our politicians would like to see the federal government find the money, go chase the manufacturers and get that paid for, whether that's retroactively or proactively. I think others are thinking that, this really needs to be managed more at a state level and a polluter level, and you have the states and then the others that are impacted go chase, the polluters. So I don't know that there's a solution there just yet. So, there's certainly funding sources that are out there that this may qualify for, but it's not necessarily dedicated towards this
Yeah.
at a national level. It's just only at those regional, very site-specific levels at this point in time.
Yeah, very, very interesting. I know local governments love unfunded mandates and trying to figure out how to make that work. But it is good to hear that we're thinking about our health of us currently and also our future of trying to make sure that we're taking care of this so that we are able to continue to sustain. This has been a great conversation with both of you guys. I'm going to ask one last question, and Daniel, I'm going to ask you to start, but also go to Patrick as well. But starting with Daniel, what final piece of advice can you share with civil engineers who want to stay ahead of emerging regulations and technical challenges when it comes to PFAS and water treatment?
So I think my my first piece of advice is I think it's a good idea to start your week or your day, like those publications you get from AWWA or WEF, the Water Environment Federation. Read an article and see, like, what's out there on the policy front, or challenges that other utilities or engineering firms have overcome on the emerging contaminants front. There are a lot of articles about PFAS, and um, a lot of people who want to talk about what they've done. So I'd recommend that first. Second, try not to reinvent the wheel. If you find yourself up against a question of PFAS treatment, try to reach out to vendors and practitioners. Whether it's through or the people at your company who have dealt with PFAS, and talk through the pitfalls and the potential challenges, what the landscape is looking like. A lot of people have been up against this. There's been a lot of knowledge that's been gained, especially in like the last 5 or 6 years. And so if you're having a problem with it, probably someone else has. So don't try to you don't have to figure it all out yourself.
And Patrick?
Yeah, I'll just add on that stay involved with your professional associations. So whether you're in a WEF or Water Environment Association, local member association, AWWA's local member associations, those are great organizations to be part of the conversation. You've got a lot of professionals working at consulting firms, utility owners, equipment manufacturer reps, that are all part of the discussion. And we compete for work, we compete for resources and staff and all that kind of fun stuff. But in those associations, we all kind of get together and we're sharing knowledge, and we are all trying to do the same thing, which is, provide safe drinking water, save the environment, make the world a better place. And we all tend to come together and have really great conversations at those events and those forums to share knowledge. I've learned so much from just colleagues at other organizations about this very topic. So I would say try to stay involved as much as you can with your professional organizations that are talking about this on multiple different levels, and how they're impacted, both at a local level as well as the national solutions that we're seeing out there.
Well, I want to thank you both. I learned so much today. It's been a great conversation, and learned a lot about PFAS, and excited to continue to see what's next in this area. All right, now it's time for our CE Hot Seat segment of the week. Patrick, Daniel, welcome. You guys ready to go?
Let's do it.
Yes, sir.
I'm going to start with Patrick, and then Daniel, you'll answer after that. Do you have any specific rituals that you practice every day? For example, do you have a specific morning ritual or lunchtime ritual, things that you do consistently that contribute to you being a successful professional?
Absolutely not. I love that question. And your I get up, I'm doing this motivational thing every day. Absolutely not. My days differ so much based off of what the issues are that we have at hand. And I just say being able to be flexible, open, and just try to reach out to everybody possible to help solve problems. One thing that we do is collaborate, and that's probably the common theme across my work day is knowing that I'm not the solution. It's the team that's the solution. So that's what I would push out there, is just keep an open mind and talk to all of everybody you network with.
Daniel?
All right. So, I don't think there's anything that I do every single day, except morning coffee. That
Okay.
is
Yeah,
a
that's a good one.
constant across every day of my life. And aside from that, I think it's important to stay active. And so I like to go for runs to sort of collect myself and my thoughts, and also stay physically active, and that helps me. That helps me keep my energy levels up at work, too. So sort of taking care of yourself is an important daily ritual.
That's great. Patrick, what is one book that you recommend to engineers regularly, or just one book that you've found to be extremely helpful in your professional and or personal development?
I think I don't know about professional development, but I thought it's very interesting to know the background from where we came from. So there's a book called Water 4.0 that kind of goes through the development of water treatment through, starting from like ancient Mesopotamia up through now. And really, the kind of the forward-looking thoughts is a little bit dated, but I think the understanding of where we came from and how societies were built around water is such an interesting topic, and it really kind of grounds us and so how important water is to society. So, I would definitely encourage if you enjoy history or kind of just want to look back at why we're doing what we're doing, read that book.
And Daniel?
Yeah, I'll have to get that one from you, Patrick. Um, One that comes to mind for me is a book called Engineering in the Mind's Eye, and so it gives sort of a history of how engineering evolved into the way that we know it today. So, starting in like workshops back in like the during like the Renaissance, when craftsmen were trying to build projects, having somebody who was sort of leading like the planning of those projects. They always be there on site, but as projects got more and more complicated, and these guilds started developing, like there's a trend towards increasing separation between the people who are thinking of how the work should be and the people who are doing the work, and how that sort of impacted our eventually evolving into engineering as we know it today. And what that book is saying is, we can't forget as engineers the sort of the spatial and like the visual aspect of the things that we design, like that moving us away from the job site, away from our actual the physical results of what we design, is sort of something that we do at our own peril, and that can lead to problems at the you know issues in the design process that get caught in the construction process, and being cognizant of that when you're designing something as an engineer. Recommended it for really any engineer who's getting into professional practice.
Awesome. Patrick, thinking back on your managers of the past, picture your favorite manager or managers. What made them your favorite?
So I've got a couple out there. They're my favorite for very different reasons. I'll tell you a brief story. Is one of my favorite managers, very, very detail oriented, made me one of the you know more detailed oriented guys I know, made me a better engineer. And he had this sadistic love for redlining drawings. And it really was one of those things where I showed up at his house on a Saturday to pick up my drawings that he had redlined. This is obviously back before we were doing everything in Bluebeam and Adobe and whatnot. And he had his daughter telling me how wrong everything was. It was great. It was, like I said, but he made me a better engineer.
Yeah.
On the flip side of that, I've had several managers that really were much more forward thinking on the softer side of skills, and particularly around sales and around some of the technical aspects of what they do. Why do we do it? How do we approach it? And really, this is just about starting the conversation and trying to find ways to help each other. And that's as a consulting engineer, and it really not even as a consulting engineer, just as an engineer in general, being able to have those conversations with your friends that are potentially your clients, or even at other organizations, about how do we just make their day better? How do you solve a problem? And if you can just solve that problem for your client, or as an industry thing, level, it makes it all that much more rewarding for us to go out there and do what we're doing.
Daniel?
Yeah, so best managers I've had, I think, well, I'm very lucky that I haven't had a bad manager since like my first job in high school. But I think some qualities that make someone a good manager is they're usually pretty clear communicators, and setting expectations, and giving you a means for your career progression. I'd say when something isn't going well, or if you're underperforming, or some deliverable wasn't up to snuff, telling you directly when there's a problem, rather than the being passive aggressive about it, or just not telling you. I think that that's important to be direct. Trying to build up their teams. When they're going through something or having a difficult time on a project. I think back to my first engineering supervisor, and I'm on a job site, and there's a red in the face contractor who's screaming at me about how well, what does to grade mean, like on the plans, and he's just giving me just really giving me the business. And I was talking with with my manager at the time about that, and he's like, look, we'll get that figured out, but remember that if you're flustered, if you feel like you're being, if you're on edge, like that blood's going to rush from your brain to the rest of your body. It's flight or fight. And so what you need to do in a situation like that is take a deep breath and take a second to collect yourself. And, I remember that to this day. And so having a manager who can sort of just bring it down to what's important and, help you progress through your career in a positive way, that's what they should be there for. And I'm very thankful that I've been in positions all throughout my career where that's been the case.
Dan, you could have summarized that by saying my name.
I was gonna say the same thing, but that's great. That's really good. All right, I've got one final question, and that is the critical civil engineering career elevator advice question. If you got into an elevator with a civil engineering student and had about 30 to 40 seconds with them, what career advice would you share with them? And I'll start with Patrick again.
I'll say first and foremost, realize you're entering a field that is really making society better. That is, whether it's the built or natural environment, we make society better. We save more lives than any doctor will throughout the course of their career, just by accurately designing, whether it's a water treatment plant or a highway or a structure. Take pride in that. And then when you do get a little bit more specialized into your area of focus, still be willing to just work on any type of project possible. Become the jack of all trades before you consider specializing even further into a specific subset of the civil engineering industry. If you can, the more well-rounded you can be as an engineer, the better engineer you will be.
Daniel?
Yeah. Don't get pigeonholed. That's a good one. Be well-rounded. Be a sponge when you're young. I'd say take notes and organize those notes so you have a record of what was said and who said it. It's also, keep in mind that if you're having a conversation with somebody and someone asks you a question and you don't know the answer, it is very okay. It's preferable to say, I don't know, and I'll get back to you on that. Don't, are we allowed to swear? Don't talk out of your ass. And sort of building off of that, know when to speak and know when to listen, know when to stand your ground too. If you're really sure about something, and you can always dig in your heels and know when to let up. So broadly speaking.
Well, Patrick and Daniel, I want to thank you both so much for joining me today. Where can our listeners connect with you?
Well, www.stanleyconsultants.com would be the great place to start. So we both love working there. I've been there for 5 years. Dan, a little less, but great company. You can also find us on LinkedIn. Just Google search or LinkedIn search Patrick Haney, Stanley Consultants. You'll find me. Same thing with Dan Stockard. And happy to engage with you. I know just in the coming months, we'll both be at several conferences. So if you're in the upper Midwest or at any of the national water conferences, you'll be able to find us there.
Search these guys out. They sure seem to know what they're doing. So appreciate you guys, and we'll talk again soon.
Thank you.
All right. Thank you, James.
Please remember you can find the show notes for this episode at civilengineeringpodcast.com. There you'll find the summary of the key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during the episode. Until next time, I wish you the best in all your civil engineering endeavors.